trigonometric ratios that can help us find the missing sides of a right triangle or find missing angle of a right triangle. So before we get started on exploring the trigonometric ratios, sine, cosine, and tangent, I would like for you to work on this warm-up. So complete the warm-up and then check your answer by continuing the video. So it says, find the missing sides. Describe your method. So what we know is that these triangles are similar. And because they're similar, that means that we know that they are the sides are proportional. All right. So are these triangles similar? Yes, because of angle similarity conjecture. Okay, and what we know is that because this angle is 30, that this angle would have to be 60, and there are two angles that are congruent, therefore they are similar. Now, in order to find the missing sides, right now we would have to use what we know about 30, 60, 90 triangles. And we know that the hypotenuse of a 30, 60, 90 triangle is double the short side, so 12, and then this one would be 8. And then finally, we know that the long side is equal to the short side times the square root of 3, and then 4 times the square root of 3. So we can use the 30, 60, 90 triangle to find the missing sides when we are given one angle and a side. Now, the problem that we would run into is, what if this was not a 30, 60, 90 triangle? With this information, we would need to have another strategy of finding the missing sides. So that's where trigonometry comes into. Trigonometry is the study of the relationships between the sides and the angles of triangles. And the relationships that we're going to discover are for right triangles in this lesson. So what early mathematicians discovered is that whenever they had a right triangle that had similar angles, they found that the ratio between the short leg's length and the long leg's length was always the same, assuming the angle was the same. So you'll see in these triangles, you had an angle of 31 degrees. And then if you look at the short leg, the ratio between the short leg and the long leg, they found that these ratios were the same. Okay? And so what that allowed them to do is they were able to come up with ways to find out the lengths of missing legs and use this idea of similarity and sides being proportional. So in this picture right here, what they noticed is that for all 4 of these triangles that have an angle of 20 degrees, they saw that the ratio between side BC and AB would be equal to the ratio between EF and DE, between HI and GH, and KL and JK. All 4 of those ratios were the same, and what they noticed was that the ratio of the sides for that 20-degree angle were the same. And so some terminology that you're going to need to know is, if we're talking about this 20-degree angle right here, the side that is across from that angle is called the opposite leg, and the side that is next to this angle or attached to that angle is called the adjacent leg. And the side across from the right angle is always your hypotenuse, so it will never be your opposite leg or your adjacent leg. Now, what they figured out was that the ratio of the length of the opposite leg to the length of the adjacent leg in a right triangle, it came to be called the tangent of the angle. And we can use this in order to find some distances of missing sides of a triangle. So if we look at this example, it says, at a distance of 36 meters from a tree, find the angle from the ground to the top of the tree, or the angle from the ground to the top of the tree is 31 degrees. Find the height of this tree. So what we know, if you zoom in on this picture, is that this angle right here is 31 degrees. We would like to find the height of that tree. All we know is the distance from the tree to where you're standing. and that is your adjacent side to the angle of 31 degrees. So if we use what we know about the ratio of if we use what we know about the tangent of an angle, we know that the tangent of an angle, which would be written like this, tangent of 31, because the angle is 31 degrees, is equal to the length of the adjacent leg in the right triangle. What you would have is the ratio would be the length of the opposite leg to the length of the adjacent leg. So the opposite leg, in this case from 31, would be the height of the tree. We don't know what that is, so we'll call it x. And then the adjacent leg is 36. So in order to solve for the height of this triangle, or the height of this tree, you would multiply both sides by 36. So you get x is equal to 36 times the tangent of 31. And what you would need to do is you would need to use a calculator. And in order to use a calculator here, you would type in 36 times tangent of 31. Now, if you're using a TI-84 or any other TI calculator, you're going to need to make sure that your mode is in degree mode, because we were talking about an angle that is 31 degrees. So if you click on mode, you can see that you have this option of radian or degree. If yours says radian, just click down there to radian and go over to degree, hit enter, second quit to get back to your problem, hit enter, and so that we find the height of the tree is 21.6 feet tall. So 21.6 feet tall. Now, in order to solve problems like these, mathematicians made tables that were related to the ratios of side lengths to angle measures. And they named 6 possible ratios. We're only going to talk about 3 of them. There was sine, which was the ratio of the length of the opposite leg to the length of the hypotenuse. There was cosine, ratio of the length of the adjacent leg to the length of the hypotenuse. And there was tangent, the ratio of the length of the opposite leg to the length of the adjacent leg. So you have a right triangle here, and you have sine, cosine, and tangent of angle A. So sine of A would be equal to the opposite leg, which is A, over the hypotenuse, which is C. So you have sine of A equals A over C. Cosine of angle A is the adjacent leg divided by the hypotenuse. The adjacent leg would be B divided by C. So cosine A equals B over C. And tangent A is equal to the opposite leg divided by the adjacent leg. So you have A divided by B. So tangent A is equal to A divided by B. And these ratios change depending on which angle you're using. So if you're using angle B, the sine of B would be the opposite of B, which is B divided by the hypotenuse, B over C. So the sine of B in this case would be equal to B over C. Now, what we're going to do is we're going to see if we can find some relationships between these different ratios. Okay, so what I want you to do, and you can follow along and instead of using a protractor and a ruler and paper, you can do this on Desmos geometry. So what we're going to do is we're going to make a right triangle on Desmos, and we're going to label angle. We're going to make it a right triangle, so a 90-degree angle, and it has a 20-degree angle and a 70-degree angle. Your numbers do not need to be the same as mine. Okay, so what we'll do here is, in fact, it's best if your numbers are different than mine. So what we're going to do is we'll label this A, and we'll label this B, and we'll label this C. And if we look at this, if we go back to our notes, we want to find sine of A, cosine of A, tangent of A if A is 20, and we want to find measure of C is 70, so we want to find sine C, cosine C, and tangent C. So if I jump back to here just to make a quick update, we want this to be C, we want this to be B. So if we look at this, the first thing we want to find is sine A. So in my case, sine A is sine of 20, and that 20 is the opposite side divided by the hypotenuse. So 1.62 divided by 4.8. So if I do that, I get, and we're going to round to the thousandths, we're going to get 0.338. 0.338. So if we go back to our notes, sine of A, when we divided those two sides where we wrote the ratio, was 0.338. And again, it was 1.62 divided by 4.8. Now, if we go back to here and look at our triangle, the next thing we want to find is cosine A. So cosine would be 4.51 divided by 4.8. So 4.51 divided by 4.8 would be 0.9395, so that rounds up to 0.940. So we have so cosine of A was 4.51 divided by 4.8. So 4.51 divided by 4.8, that gave us 9.940. And then finally, tangent of A would be equals to the is opposite over adjacent. Okay, so opposite over adjacent, if we go back to our triangle, would be 1.62 divided by 4.51. 1.62 divided by 4.51. If we type that into our calculator, we get 0.3592, which would round to 0.359. So we have those ratios for sine, cosine, and tangent of the 20-degree angle. Next, we're going to find the sine, cosine, and tangent of angle C. So sine of C was equal to, would be 4.51 divided by 4.8, which would give us a 0.940. And again, if you look at cosine of C would be adjacent 1.62 divided by 4.8. Okay, 1.62 divided by 4.8. And if you look at this, we've already done that. 1.62 divided by 4.8 was 0.338. And finally, tangent of C would be equal to 4.51 divided by 1.62. If you go back, if we look at this, opposite is 4.51 from 70, adjacent is 1.62. Opposite divided by adjacent is 4.51 divided by 1.62, which is 2.784. 2.784. Okay. Now, what would be ideal here is if you make your own triangle and then write it down and then find the average of our two numbers and see what you get here. Now, if you look at step 5, it says, what observations can you make about the trigonometric ratios you found? What is the relationship between the values for 20 degrees and the values for 70 degrees? And if you look at this, you'll see that if you look at sine A, you got 0.338. If you look at cosine C, you got 0.338. If you look at cosine A, you get 0.94. If you look at sine C, you get 0.94. And then there's a relationship between the tangents as well. But if you first look at this, you'll see that sine of A is equal to cosine of C. Or if we write this, sine of 20 is equal to cosine of 70. And we have cosine of 20 is equal to sine of 70. Now, if you look at the tangents are not the same, but if you look at the ratios, you have 1.62 over 4.51, 4.51 over 1.62. The numerator and denominators are flipped. And remember, when you have a ratio where the numerator and denominator are flipped, those are called reciprocals. So what we can say is tangent of 20 is equal to, or we can say tangent of A is equal to 1 over tangent of C, or you can say tangent of C is equal to 1 over tangent of A. So the tangents of those angles are reciprocals of each other. All right, and if you take a second to think about why this might be why this relationship exists, just look at the numbers. 20 and 70 add up to 90. Okay, so these angles are complements of each other. That means they add up to 90 degrees. All right, so what we're going to do is we're going to see if that is the case for all complementary angles. Now, before we move into that, just talk about how to find this on your calculator. Again, if you're using these, you have like sine of 20. You just type in sine of 20, it gives you your number, 0.342. So if you look at that, 0.342, if you go back to look at what we had 0.338. 0.338 would round up to 0.34, so they're pretty close to being the same thing. Cosine of 20. Cosine of 20 is 0.9396. That would round up to 0.940, which was what we had. And then if you look at tangent of 20, you get 0.363, which would round up to 0.364. We had 0.359, so 0.359 would round up to 0.36. So pretty close to being the same, or pretty close to being the same answer. So if we look at this, what you'll see is that how do our trigonometric ratios compare with the trigonometric ratios you found on the calculator? They are very close. They are roughly the same number. Okay, so they're roughly the same with a little bit of rounding here and there. Now, what we just said was, what we noticed was that sine 20, cosine 70, we noticed that 20 and 70 are complementary angles. They add up to 90 degrees. And our question now was, is that the same? So is the sine and cosine of complementary angles, are they the same? So let's check that. Is sine 40 equal to cosine 50? 40 and 50 are complementary. And so based on what we saw earlier, the sine of one should be equal to the cosine of the other. So if we take a look at our calculator, we have sine 40, and then if we do cosine 50, you'll see that they are the same number. So that does work. And then if you check sine 30, would that be equal to cosine 60? It would be. And the same thing goes, if you check cosine 40, that would be equal to sine 50. And so what this means is that we can say that complementary angles have the same sine and cosine values. Okay, so what that means is if you have 30 and 60, the sine of 30 is equal to the cosine of 60. The cosine of 30 is equal to the sine of 60. All right, so again, if you have complementary angles, we know that the sine and cosine values of the complements are the same. So if we take a look at this example, it says find the length of the hypotenuse of a right triangle if an acute angle measures 20 degrees and the leg opposite the angle measures 410 feet. So we're going to go ahead and draw a triangle that looks like a right triangle. It says find the length of the hypotenuse. So the hypotenuse is over here across from the right angle, and you have an acute angle measuring 20 degrees. We'll say that is right there. And the leg opposite of that measures 410 feet. Okay. So again, it doesn't matter what our picture looks like. My angles of 20 degrees are down here. You could put it up here, but it doesn't tell us exactly where it is, so we can put it on either angle. So if we take a look at this, we want to find the hypotenuse. We have the opposite side from 20 degrees. So what we can do is we can say we want to find the sine of 20. So what you want to do is you want to ask yourself, which trigonometric ratio uses the opposite side in the hypotenuse? that is sine. Sine of theta is equal to the opposite side divided by the hypotenuse. So you have sine of your angle, which is 20, is equal to 410 divided by our hypotenuse. We'll call that x. We would cross multiply. So you'd have x times sine 20 equals 410. Divide by sine 20 on both sides, you get 410 divided by sine 20. You go to your calculator and you type that in. You have 410 divided by sine 20. And you find out that your missing leg is 1,198 feet, or say 0.8 feet. We'll round to one decimal place. So we have x equals, or our hypotenuse is equal to 1,198.8 feet approximately. Now, sometimes we will want to be able to find we might know the ratio of the legs, but we'll need to find the acute angle. So we might want to find the measure of one of the acute angles that's in our right triangle. To do that, we're going to use what's called the inverse tangent. It looks like this. It says tangent to -1 power, or inverse tangent. So what you need to know about the inverse tangent is the inverse tangent undoes the tangent function. Okay, so what this looks like is when you take the inverse tangent of the tangent function, they cancel out, they undo each other, and you're left with just a, which would be the angle that we want to find out. So if we look at this, it says a right angle has legs of length 8 inches and 15 inches. So we have to draw our right triangle. Maybe, come on, notability. We'll say this is the 8 and this is the 15. Find the measure of the angle opposite the 8-inch leg. So the 8-inch leg is the opposite side. We want to find this angle right there. So we're going to use opposite, and then we have our adjacent side. So that's going to mean opposite over adjacent, or if we have our opposite side and our adjacent side, we want to use the ratio that has just those two sides. So we have tangent is opposite over adjacent. So you know tangent is x is equal to 8 over 15. And you'll see we want to find out what our angle is. So to do that, we take the inverse tangent of both the sides. The inverse tangent and the tangent function cancel each other out, leaving you with your angle measurement. And it says your angle measurement is equal to the inverse tangent of 8 over 15. To find that, you go to your calculator. The inverse tangent button is above the tangent button, so you have to hit second tangent, and you have 8 divided by 15. You'll find out that the angle is 28.1 degrees. So we have 28.1 degrees. A few more examples. You'll see in this problem it says find the measure of angle T. So again, here's the angle we want to find. Ask yourself, what sides do you have? We have the hypotenuse of the triangle, and we have the side that is adjacent to T. So that tells me we want to use cosine, because the cosine ratio is adjacent over hypotenuse. So if we fill in what we know, we have cosine of T is equal to the adjacent side, 5 divided by 6. So we want to find out the angle measurement, so you're going to take the inverse cosine of both sides. So the inverse cosine and cosine cancel each other out. They undo each other, so you're left with the angle T is equal to the inverse cosine of 5 over 6. Again, you go to your calculator, second cosine, that gives you the inverse cosine, and we have 5 over 6, and that gives us 33.5. We rounded up to 33.6. So the missing angle is 33.6 degrees. In this problem, this is using the conjecture we have about the complement of angles and their sines and cosines. It says in right triangle RST, measure of angle R is not equal to measure of angle T. Let sine R equal X and cosine R equal Y. What is sine T minus cosine T? So if you look at this, we know sine r is x, we know cosine r is y. Because it's a right triangle, angle r and angle t are complements. So that means they add up to 90 degrees. We know that if sine r equals x, then we know that sine of t is going to be equal to cosine r. And we know that cosine t is equal to sine r. So again, what we have here is it asks what's sine t minus cosine t. So sine t minus cosine t. Sine t is equal to cosine r, so cosine r is y. So y minus cosine t is equal to sine r is equal to x. So sine t minus cosine t is equal to y minus x. So go ahead and begin working on your homework. If you have any questions, email me, message me on Remind, or you can ask next day in class.